Okay, boys, this is two examples from your Chapter 15 practice. Questions number 2 and 3, because those are the ones that are like most of the other ones. The thing you need to remember in question number 2, H sub 0 is the null hypothesis, and it's always the equals case. So make sure that always you'll select the equals for there. And then it equals whatever the accepted value is or the population mean. Just make sure you don't use X bar. So in this particular case, it's going to be 23. The X bar, do not use that in the null hypothesis. The alternative hypothesis, you have to choose whether it's less than, greater than, or not equal to. It will not be the equals case. And in this one, it just says that whether the true mean is different from 21. So it doesn't indicate whether it's less than or greater than. So we're going to choose not equal to, which makes this a two-tailed test. These two numbers here have to be the same, and they're both the population mean in this particular case. Okay, after you decide the null hypothesis, then the next thing you do is find the z-value and the p-value. So in question number 3, it says an environmentalist group collects a liter of water from each of 52 random locations along a stream and measures the amount of dissolved oxygen in each specimen. The mean is 5.65, that's X bar. Is this strong evidence the stream has a mean oxygen content of less than 6 milligrams per liter? Suppose we know that dissolved oxygen varies among locations according to a normal distribution with sigma equal to 0.79 milligrams. And we're going to be using an alpha level of 0.05. So in this case, N is 52, X bar is 5.65, mu is 6 liters, sigma is 0.79. So again, the null hypothesis, H sub 0, is always the equals case. And in this case, it's going to be 6. You do not want to use X bar there. Because this problem indicates, they want to know, is there evidence that the mean oxygen content of less than 6? So obviously the researcher thinks there's something to indicate it might actually be less than that. So this is going to be a one-tailed test, with the alternative hypothesis being the mu is less than 6. Okay, next we have to calculate our z value, our z-score. So this is still using the same formula we've used before. Z equals X bar minus mu over sigma divided by the square root of n. So in this problem, X bar is 5.65, mu is 6. This mu will always be the number that's in your null and alternative hypotheses. This will always be from the sample. Sigma was given to us as 0.79 divided by the square root of n. There were 52 samples, so n is 52. Now when you put this in your calculator, just a couple of notes. You might want to enclose the numerator in parentheses. The other thing, you can just do 5.65 minus 6, press enter to force it to do the subtraction. And then divide. You're dividing by both of these, so make sure you put the denominator in parentheses. 0.79 divided by the square root of 52. We get a z-score of negative 3.19. And then you're going to go to table A, and you're going to look up a z-score of negative 3.19, and you get 0.007. Oh, whoops, nope, you get 0.0007. And we're going to compare that with our alpha level, which is 0.05, and it is less than 0.05, which indicates that it is significantly different than the accepted mean. And so we are going to reject the null hypothesis, because this means that there is 0.07% chance that that was just due to random sampling error. Over here in our problem, our z-value is a negative 3.19. Our p-value, this is what we looked up in the table, 0.0007. If the p-value is less than the alpha value, then we reject the null hypothesis, H sub 0, and conclude that there is evidence that the stream has a mean oxygen content of less than 6 milligrams per liter. Hope that helps.